Okay, we're going to do a length of a curve again. And here I have the curve y equals x to the 3/2. So just remember the formula. That was okay, so right away, the piece of information we're looking for is dy dx, and we need it squared. So let's go ahead and find that. Here's y of x. So dy dx is going to be 3/2 x to the 1/2. Okay. Might as well just find the square of that right now, since we're after. Since that's what we're after. If I square this whole thing, I get 9/4, and if I square this, I end up with x to the 2/2, which is just plain x. Okay, which is just 9x over 4. Okay. So let's see here, and I'm going from x equals 0 to x equals 4, so it looks like the length of this curve is going to be 0 to 4 plus 9x over 4 dx. Okay, this one, actually this one doesn't look like it'll be too bad. So let me just go ahead and do a U-substitution for the whole thing. That'll be 1 plus 9x over 4 du will just equal what? 9/4 dx. Okay, so dx will be equal to 4 du over 9. Okay, so let's see if I can't kind of build on this a little bit. Okay, so I still have the actual integral in focus up here. And yes, we're going to substitute the entire thing. So integral of u to the 1/2 is equal to what? 4/9 du, right? That's what dx was equal to. Okay, and let me see here. Let's go ahead and pull that constant out. Okay, that's going to equal 4/9 u to the 3/2 over 3/2, which is equal to 4/9 times 2/3 times, back to my U substitution, 1 plus 9x over 4 3/2. Okay, so let's do some simplification here. Okay, let's do some more simplification. This is just going to be what, 8/27. And that's going to be 1 plus 9x over 4 3/2, and we're evaluating from 0 to 4. And there I go, running out of paper again. Okay, didn't really budget that too well. Okay, so what's this? This is 8/27. I really hope you guys aren't lost right now. I mean, I'm just doing the fundamental theorem of calculus right now. So, I mean, you know, I hope you got the earlier part. So that's just let's see, if I plug the 4 in here, that's going to cancel out. So that'll just give me the 9 to the 3/2 minus 1 plus 0. Well, that's just 1. Okay, so that looks like it'll give me 8/27. Looks like 10 to the 3/2 minus 1. Thank you for bearing with me. Okay, 10 10 to the 3 halves, all that is that's a 10 square root of 10 square root of 10, which is 10 square root of 10. Okay, so let's see here. That'll be 8/27. And let's see here. That'll be -1. So we end up with, what do we do? 80 square root of 10 minus 8 over 27. Okay. I'm putting in my calculator right now, by the way. Okay, so that's approximately 9 units long. Okay, it got pretty out of hand right there. But let's just think about what does x to the 3 halves look like, you know? X to the 3 halves. Okay, I just grabbed this on the calculator, and x to the 3 halves, apparently it kind of looks like that. So if I was going from 0 to 4, how long the curve is, well, it's obviously going to be longer than 4 since I've got some vertical distance to kind of traverse. And it's kind of rectangular shape, so it's going to be a little bit taller than it is long. So to say that this is approximately 5, I don't know. So all I'm saying is basically 9 units long doesn't seem too out of whack. You know, unfortunately, I don't have a way to check this at the moment, so you're actually going to have to put your trust in me, which is kind of weird. So I hope I didn't confuse you on that one. Like I said, the worst part about that one was using the fundamental theorem of calculus, and you know, going back to evaluate the damn thing. So and just going back, you know, oh, here I'm getting crazy. Right here, here's what we ended up with. And this one was actually pretty easy to work with too. We just knocked it out with the U-substitution. So, you know, if you need some more examples of that, go ahead and let me know. I'm gonna try to put one more on here. I'm gonna try to, I want to get another factorization one in there. I want to get another like trig substitution one in. Okay, so yeah, just leave a comment if you need some more examples. Thanks for watching.